Hi, this is Mr. Cardoso, and in this example we are just going to look at solving this trig equation here. It's a quadratic trigonometric equation, and we have sine 2x, which can be written as 2 sine x cos x, and cos 2x can be written in a number of ways, but notice that we have a sine squared x here, so it's actually helpful to write this as cos squared of x minus sine squared of x. So this whole thing boils down into all of this. Okay, and then we have this plus sine squared x over here. Now that's nice, because if you look carefully you'll notice that minus sine squared x plus sine squared x actually cancel out. So we have 2 sine x cos x equals cos squared of x. Now we bring everything to one side and we go 2 sine x cos x minus cos squared x equals 0. Okay, so now we have to try and factor this, and notice that we have a cos x common here, so we can pull that out. So we take out the cos x and we have cos x, and then we're left with 2 sine x minus cos x because there's a cos squared x equals 0. Okay, so that means that either this has to be equal to 0 or this has to be equal to 0, as if we are factoring. So cos of x equals 0, or 2 sine x minus cos x equals 0. So we have these two equations to solve. Now this one's easy, and by the way, I didn't write down the domain here, so let's say this is 0 is less than or equal to x, which is less than or equal to 2 pi. So let's go from 0 to 2 pi in our domain, and that's the domain we're going to solve over. So cos of x is equal to 0. Now if you look at your unit circle, just very quickly here, and if I draw a quick circle, cos of x, where's cos of x equal to 0? Now cos of x is going to be equal to 0 because cos of x is actually on the x-axis. It's going to be equal to 0 at pi by 2 and 3 pi by 2 in one circle. So x is equal to pi by 2 and 3 pi by 2, and then for good habit we write plus 2k pi. Now to solve this one over here, this equation over here, it looks a little bit tricky because none of these are squared. So let's take the cos x to the other side. Okay, now what we're going to do is we're actually going to divide by cos. If we divide both sides by cos, what ends up happening is we get sine over cos, which we know is tan. So 2 tan x equals, and cos divided by cos gives me 1. Okay, so now we can solve this. So we get tan x equals 1 over 2. Alright, so what we're going to do now is, because our domain is from 0 to 2 pi, I don't have to play around with k. If I let k be 1 here, where k is any integer, if I let k be 1, I'm going to add 2 pi to these two, and what's going to happen then is I'm going to be more than 2 pi, and so I'm going to be out of my domain. So if I draw a box here for my final solutions, so it's right here, final solutions. Okay, so then I'm going to have pi by 2 in there. I'm going to have 3 pi by 2, and this equation is not going to yield any more solutions. Over here I still have yet to solve this one. So I'm going to need my calculator for this one, and I know that if I take the tan inverse of 1/2, I'm going to get x equals 0.46. And that's by taking the tan inverse. So tan inverse of 1/2. And make sure your calculator is in radian mode, since our domain is given from 0 to 2 pi. And that's obviously in radians. So this is one solution. Now notice that 1/2 doesn't correspond to any special angle, and so that's why I use my calculator. Here I know that 0, for the cos of x equals 0, I know these correspond to special angles, so I must state those exactly. So now this is one solution. 0.46 radians is one angle. Now I know for tan has a period of pi, so if I add pi to this, okay, and I'm going to get to here, and basically my tan will be the same on my unit circle. So my other solution will be 0.46 plus pi, or 180 degrees, to get to my other solution in one unit circle. And this is approximately, and this is plus k pi for good habit. But again, I know if I add pi to this, I'm going to get this one anyway. And if I add pi to this one, I'm going to get back up here. So these are my only two solutions. And so I'm going to write down over here in my final solution 0.46, and that's radians. And 0.46 plus pi, I believe, is around 3.6. So there are my final solutions. Notice that these ones had to be done with a calculator and not exactly. These ones could be expressed exactly as 0 corresponded to a special angle on the unit circle. And the trick here was solving this part, dividing by cos x. That was a little bit tricky. Okay, I hope you enjoyed that example.